All right, welcome to AP Calculus. We're in lesson 2-1. Today's date is Monday, September 13th, 9/13, 2021. Our objective today, Ellery, read it.
Find derivatives of functions using different forms of negative exponents and radicals.
I've seen you read that hard book, so I know that you can read hard words, but you're good. All right. Fox and socks, right? X to the power of -4. Get rid of the negative exponents. How could you do that, Fern?
You flip it.
Flip it. So it used to be x to the power of -4 over 1. Now it's 1 over x to the power of
4.
positive 4. Exactly. Yep. Sergio, go ahead and get rid of negative exponents. How would you do that?
The opposite of x to the power of 2 over 1.
Exactly, over 1. And you don't really need the over 1, so we'll just call it x cubed. Good. And then, ooh, this is a particularly tricky one. We'll give it to Ellery. How do you get rid of the negative exponent?
2 over x to the 8?
It is indeed 2 over x to the power of 8. A lot of students will mistakenly put this 1 over 2x to the power of 8, which is incorrect. It's incorrect because the 2 does not have any negative exponent. They would also need a -1 of its own in order to flip. If it doesn't have anything, it's left behind. All right, so reading on our notes, to switch the exponent from a negative to a positive, only move the variable between the numerator and the denominator. So only move the variable. And that's not always true as a math fundamental, but when you're talking about AP Calculus, usually the variable is going to be the only thing with a negative power. You're very rarely going to have a 2 to the power of -1 times x to the power of -8. All right. So what about roots? We also need to be fluently able to convert roots to exponential form. This is called radical form. Let's give it a Fern again. Fern, square root of x is what? It's x to some power.
X to the second.
Good guess. So x to the second will get rid of the square root if I have this thing to the power of 2, and then those will cancel out. I agree. But this one is just going to be to the power of 1/2. Why? Because this is a power of 1 on the inside. The index of this radical is 2, so you do 1 over 2. Fern, try this one. What is the cube root of b in terms of exponential form?
Would it be 1 over 3?
It is indeed 1 over 3. And Sergio, what is the 4th root of x cubed?
Is it x 3/4?
X to the 3/4. It's that simple. The only tricky thing that we have to remember is if I don't have any exponent on the inside, then you assume that the exponent is 1. And whenever I don't have any index on the outside, you assume that the index is 2. Those are the two tricky ones. All right, so there's two different ways of writing the derivative. There's this one, which is called f prime of x, and then there's this one, which is the derivative with respect to x. I'm going to write that English word that you say out loud underneath this. I pronounce this f prime of x. And that's how I'd like you to pronounce it as well. So we'll do the kindergarten method of repeat after me. F prime of x. F prime of x. F prime of x. F prime of x. Ah, there we go. Okay, we can all say it. All right. Next, this one is a little bit longer. I'm going to type it because I'm a little bit faster at typing, and I'm also getting some weird lag from recording the video. The derivative of, and then we're not taking the derivative of anything. Usually there's going to be something on the right-hand side there, so I'm going to leave that blank. The derivative of blank with respect to x. And just to keep us in the know-how of what's going on, usually you'll have like something right here. D dx is not the correct way of saying this, but you kind of think of the derivative with respect to x of this thing. It's usually some sort of function out here. So we'll say the derivative of blank with respect to x. 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 There we go. All right. So let's go ahead and take our first derivative. Let's see if you can find the power here. The derivative of 5 with respect to x is how I pronounce this thing. The derivative of 5 with respect to x is 0. The derivative of -2 with respect to x is 0. And in fact, the derivative of any constant, k for constant, is a running joke in all of AP Calculus that constant is spelled with a k like this, constant. K, for some reason, in all of AP Calculus, they just love using that as a number. Think of k as 2, 5, -3, pi, just some number. The derivative with respect to x of some number is always what, Sergio? 0. We'll forget that later. It's okay. And
Basically, if there's not a variable, it's just 0.
when there's no variable, it's going to be 0 every single time. K for constant. All right, so that's one rule under our belt, the constant rule. Let's talk about the linear rule. What happens if I only have x? I could have 3x, -2x, 12x. I cannot have x squared, x cubed, x to the -1. These are all x to the power of 1, which means it's a line. It is a linear function. All right, Ellery, do you know these? Putting you on the spot. You did do this unit like last year.
I know, I did.
The derivative of 3x with respect to x is 3.
Like, okay, I remember that now.
Ellery, the derivative of -2x with respect to x is
-2?
-2. Ooh, let's give the tricky one to Fernando. The derivative of 12x plus 1 with respect to x is
12.
You are correct, 12. And I'll tell you why it's correct. It's a little bit tricky, but whenever you have parentheses, just like with constants or any polynomial term on the outside, you distribute. This is really saying the derivative of 12x, 12, plus the derivative of 1, which is 0. So always think about distributing the derivative. It is a rule. So as a, yes, question, go for it.
So what if it like 12x plus 1x?
Well, then you would simplify 12x plus 1x into 13x, and just it would become a nice simple function. But that's a good question. I will do a higher level of that question on the back, yeah. What happens if I have the derivative of x squared plus x, if I have two different powers? But in general, if I just have an x, like this notes has it on our paper, if it's just x and it's some number in front of the x, the answer is just whatever that number was. So the derivative of square x is square, whatever that square was. All right, I consider those to be our baby derivatives. Let's talk about the overarching rule. There is one common thread. If you know this one rule, you can take the derivative of all of these. It encompasses the constant rule, it encompasses the linear rule, and I call that the simple power rule. We're on the back. On the simple power rule, I will tell you the formula, but let me do a few examples here. I'm going to do one example, and you can see if you can find the rule. So one thing I should add in here is the derivative with respect to x, d dx, of x squared. The derivative of x squared is 2x. Two things happened there. The first thing that happened was I no longer have an exponent of 2. I now have an exponent of 1. The other thing that happened was this 2 disappeared, and for some reason I have a 2 down here now. Let me do a second example to see if we can discover what this rule is. The derivative with respect to x of, let's do x cubed. Ellery, you want to take a shot at it?
Yeah.
Go for it.
Would it be 3x?
Close. 3x.
Oh, 3x squared.
3x squared. What happened here? The power changed. It was 3, now it's 2. It was 2, now it's 1. And what happened again is I magically have a 3 out front. I'm wondering if Sergio or Fernando are able to find this next one. The derivative with respect to x of, let's just make it nice and easy, x to the power of 4. Fern.
Would it be 3x to the third?
So close. It is to the power of 3, x to the power of 3, because it goes down, and it's 4x to the power of 3. Yeah, you're seeing that. The 4 comes down in front, and then this goes down by 1. You see it, Sergio? Nice. And that's a rule. This is how you make it a little bit more formal. You say whatever that power is, you multiply that. So if I have 1x to the power of n, this is going to be nx instead of 1x to the power of, well, it used to be n, now it's n minus 1. And that is the simple power rule. And that actually applies to our previous rules. Let's come back to the front side. Look at this. When I was taking the derivative of 3x, this was really the derivative with respect to x of 3x to the power of 1. The 1 gets multiplied by 3. 1 times 3 is 3. And the x goes down a power. X was to the power of 1. It goes down to the power of 0. And anything to the power of 0 is 1. This is really 3 times 1. Or even more formally, 3 times x to the power of 0. Which is just 3. And check it out again. What about the derivative of 5? It doesn't really have a good way of thinking about this because you might think, oh, it's x to the power of 0 and it goes down a power. That's just the derivative of a constant rule. I guess it doesn't really encompass that rule. I lied. Let's try some examples. Sergio, the derivative of x to the power of 5 with respect to x.
So 5x to the power of 4.
There it is, 5x to the power of 4. Ellery, the derivative of x to the power of 40 with respect to x.
40x to the power of 39.
There it is. Ooh, okay, Fern, we're giving you the difficult one. Here you go. The derivative of 3x to the power of 7 with respect to x.
Would it be 21?
21
To the power of 6.
x to the power of 6. Exactly. These two numbers, 7 and 3, get multiplied together. Good job. All right. I've given you one form, the derivative with respect to x format, but I can also give you the f prime format. If I tell you that your function f of x is 2x to the power of 5, then my question now is, what is f prime of x? It's the same question. It is asking, take the derivative. Take the derivative, Sergio. What is f prime of x?
So it's 10 to the power of 4.
To the power of 4. Exactly. And our final hardest challenge for Ellery. If g of x is the square root of x, what is g prime of x? Everyone rewrite this because you cannot take the derivative of a radical, but you can take the derivative of something with a power. Again, this is called the power rule. You have to have it to a power.
Put this into x to the 1/2.
Exactly. And then
It would be 1/2 x to the power of negative 1/2.
exactly. And keep going because I mean, this might be a multiple choice answer and being like, okay, there it is. But because multiple choice answers typically give you an answer that is in the hardest possible form, they probably want you to do another step to this. So be comfortable, all of us, by converting this into a positive exponent. What would that be, Ellery?
So then this is 1/2. It's 1 over 2x squared?
Close. 1 over 2x, and now instead of being a positive 1/2, or instead of being a negative 1/2, 1/2, and do another form change again. X to the power of 1/2 is, what is this thing? Is root x. So this is 1 over 2 square root of x. And I could go farther because now we have a radical in the denominator and you need to rationalize the denominator. I'm going to keep it right there. Usually that's as far as it'll go for the AP test. But again, be comfortable using all these rules because you don't know what sort of multiple choice question they're going to throw at you. They're going to make sure that you know your forms. And that's all I have for you guys today.